Howdy. How's everyone tonight? Leave it to me to schedule a live stream on Super Bowl Sunday, but this is live stream number 3, and today we're going to model this. It's a glue tip applicator that we use at work. Pretty fun to model up to. It poses a couple of interesting challenges because it has a cutout and a couple cutouts in it that need to be dealt with, and it's got 3 or 4 different diameters. But what we're going to do is we're going to use the user parameter settings in Fusion 360 so that when the engineers want to change this applicator nozzle or any parameter on it, if they want to make it bigger round, a bigger delivery hole, a different bead pattern, instead of changing the drawing, we can just change the parameter settings in Fusion and it'll automatically update the drawing. So not only will it update the model, which then you could send the step file out to a machinist to have it CNC machined, or it'll automatically update a drawing that you can send out to a guy that would manually do it, or you could after you get it to the model that you like, you can save it as an STL file and print it. And what the engineers at work, they just got, let me see if I can turn this on, they just got a Marked Forge printer. It's a carbon fiber printer or carbon fiber printer. And it's pretty nice, not going to lie. It's got a pretty enclosure, and the parts that they've made so far has been pretty good on it. But this applicator nozzle is, we mount it up into a robot, or let me rephrase that. We mount it into a head that's mounted into the robot, and it goes around the glass. I have a short video here I can show you. It goes around the glass, and it shoots a specific size bead. And sometimes that bead needs to change based on, the condition of the glue, the viscosity, blah, blah, blah. But anyway, the engineers can change that. So when they change it, the easiest way to do it, besides just telling a guy, is if you have stuff documented, as anything should be, you can just change these parameters. So what we're going to do, let's crank up Fusion 360, and then this is what we're going to draw right here, not including the Freightliner logo. That'll be another video live stream all by itself, because I don't remember how I did it. I don't know if I brought in an SVG or a STL or even a DXF. I don't remember how I did it. More than likely I brought a DXF and I projected that onto that surface, or I did it the other way and extruded it up through the bottom. I don't remember. It helps if you could see it. So here, this is what we're going to model. The glue nozzle, minus the Freightliner logo, of course. But it's just a glue nozzle. But we're going to use the parameter settings in Fusion 360. So it's the table setup that has all measurements in it. So it's, instead of using a dimension as an expression, instead of dimensioning the drawing, we're going to use the expressions to do it. So instead of naming a diameter or a length 3.25, we're going to type in the dimension of overall length, and it'll always be referenced to this table. So I went and printed out the drawing, so I have all my dimensions except for one, and I'll just add in this parameter. So the parameter that we need is, go back here, the parameter that we need is between the base of it to the center of the pin. So what I'm going to put in here is base to center of pin. I keep it pretty simple, so base to center pin. And that measurement, just done with calipers, is 0.472. So now I have all my dimensions, my parameters set. So we can go ahead and start sketching. So we're going to start a sketch. The way I normally do it, since it has these cutouts here, is I usually start with a square, and we'll dimension that square the size of the biggest diameter. So in this case it's 0.785, but we're not going to use that. We'll use the tip diameter, which is this side here. This is the base side, this is the tip size. So we'll create a sketch, we'll choose a plane, and then we're going to draw a rectangle. get my computer to work in here. We're going to draw a rectangle, and the dimension of it is 0.785, like I said, but it's what we're going to use is the tip diameter. So as I start typing in tip, anything, if I would have typed in like diameter, anything that had the diameter measurement would pop up in this box down here. So I want it to be the tip diameter. So I just hit enter. And then, of course, I need to dimension this, so I'll hit D on the keyboard for dimension. And instead of putting the 3.25, we know the overall length. So I hit overall length and hit enter. So that defined that part of the sketch. So we can go ahead and we can stop the sketch here, or we can keep on. You know what? I'm going to stop the sketch here. We're going to press pull it, which is make it a solid. We're going to choose our face, and we're going to give it a depth. And I don't want 1. Again, I'm going to use the user parameter settings, and I'm going to type in the tip diameter. So tip diameter. And hit enter. So now I have a square box, or a rectangle box, for lack of anything else. And that represents the overall shape, or the overall size of it. So now I can go ahead and draw these parts here. Let me get this one so we're about the same looking. We'll draw this part into it, and the bead profile into it. This is the locking pin. So when it goes up into that the collar that's built onto the robot, we put it in, and it's got an 1/8 or 3/16 locking pin. Not sure which size it is. This measures 3/16, but I'm sure there's some clearances for that pin to slide in. So we'll start another sketch. Whoops, go back to the one we're drawing on. Start another sketch, and we're going to do it on this plane. So we can go ahead and draw that half round or the circle where the locking pin goes, but we got to remember that this is a smaller diameter up here on the top. So what we need to do is define that diameter first, and we can make a couple construction lines, and that would just help us to get where this pin needs to go. So I'm just going to draw a couple real quick dimension or some construction lines, and the easiest way for me to do it is you go down here, you see where you have your midpoint toggle on, and come out here, and we drew a line. I'm just going to hit OK, and then I'm randomly going to choose another spot up here and do the same thing and hit OK. Now I'm going to escape out of that, and I'm going to highlight both of these, and I'm going to hit construction over here on my sketch palette. Over here. So they turned a dotted line. So those are just construction lines. Now I can dimension it. So I'm going to hit D for dimension, and I'm going to dimension this right here. I said it was. D for dimension. Of course, it never works when I want it to work. And there it's telling me that, I placed it 3.20, but I need it to go to that parametric, or the user parameter that I set in there. And in this case, it would be half of the base diameter. So if I type in base, it's already there, and I need it to be half, so I'm just going to divide it by 2. And then it spaces it out exactly where I want it. So now I'm going to draw a center circle here, anywhere on this line. And the dimension for that is pin diameter? Yeah, pin diameter. So I just started typing P, and it's already there. So pin diameter. And I hit, oops, I said I hit enter. So I hit enter. So it's 0.188 or 0.1875. Now I need to dimension it from the end to the center. So I hit again D for dimension, and I go from the end to the center, and I come up, and that is the base to something, base to center pin. So you just click that, and now that's dimensioned. We don't need, we can trim that off if it's, doesn't look good to you, or, but I'm going to leave it there for now. So now we've got where the pin goes. So we'll just leave that alone, and we'll come over here to this side. So now I'm going to hit, we're going to place the bead profile. So again, I need a couple construction lines, or at least one construction line, or might not need any. We'll try it without any. Let's see how it goes. Since I drew a center rectangle, I have this guideline here, and I can catch off here. So I'm going to draw a center circle, and if I hover down, you see I caught the midpoint. And if you just scale back, you see the blue dotted line. and that just lets me know that I'm still perpendicular to the midpoint. So now that diameter is the bead diameter. So I just type in bead diameter and hit enter. Hit enter. Now I need a couple lines on here. Let's zoom in so you can see. A couple lines for here so I can get the size of the bead. Geez, hard to figure out what to call some of these things sometimes. So I'm gonna hit L on here, or I'm gonna go up here and hit the line here on my sketch palette. So I'm just gonna draw it anywhere, and you can go around the circle, and you can see where the tangent constraint comes in. You can do that, or you can come back later on and put a tangent constraint in. And I'm gonna draw this one weird, just so we can show what I'm talking about. Excuse me. So now I need to dimension this also. So to do that, I'm going to draw just a little line in here so I can help out with some of my dimensions the way I like to do them. Whether this is right or wrong, this is the way I like to do it. So I'm going to draw just a little construction line right here. I'm going to check OK. I'm going to escape out of that. I'm going to highlight that line, and I'm going to hit construction here. So it turned it dotted. Now I can go ahead and dimension all these tolerances, or all these features. So I hit D for dimension, again, hit the right letter on the keyboard, from here to here. And that dimension is going to be half of the, what did we call it? The bead width. So we'll do bead, we'll see what I named it. Bead height, bead width. So it's bead width divided by 2. Oops, and I need to have this to stay up here, so I needed to take that tangent constraint out of there. So let's back up here. Let me get rid of that tangent constraint. So now we're going to dimension that the bead width divided by 2. That still did it. That's weird. I wonder if it'll let me do a coincident. Where's that sucker at? Horizontal, vertical. Right here to right here. There we go. That'll work. That just lined up these two dots here. A horizontal, vertical constraint. So now it shouldn't move. And then we need to dimension the bead width, which is right here. And instead of putting in a measurement, I'm just going to put bead width. But then you see how the profile is. I need a tangent constraint here, and I'd probably need to put a tangent constraint here too. So down here in the sketch palette, under constraints, I'm going to hit tangent. I'm going to say this line to this circle's tangent, and this line to this circle's tangent. So now it's not locked down because I could draw a line here, and that would lock it down. But we have these dimensions in it, so we'll just leave it like that. I'm going to trim the excess off here. So that's pretty much got that part of it done. You know what? Let's draw this line in here so then I know it should turn everything black. Or it didn't. Oh well. Alright, what else we got to do here? I think that's it. So we're going to stop that sketch, and I'm going to rotate this thing around. And what we're going to do next is we got to draw the we got to put all the radius or the diameters here. So we have the big diameter on the tip side, we have the small diameter on the base side, and then we have the center diameter through the hole. So I'm going to draw on this plane right here. So let's see, create a new sketch on this plane. And the easiest way to draw a circle, I'm going to turn this other sketch off so we don't see it, is, let's see, sketch 2. Is draw a tangent circle. So this box is the largest diameter that I use. So I'll draw a tangent circle, go down, pick circle, a 3-point tangent, and all I'll do is I'll pick those 3 things, and or 3 sides of the box, and it'll snap to the tangent, and then we should be good. So no matter what size of box we change, no matter what we change to this box in our initial parameter settings, since we set the box diameter or the rectangle diameter at the tip diameter, it'll always change also. So just for we're going to look at it to see, and it is set 0.785, so no need to dimension it. So, and then the next one is, now that I drew a tangent circle, I have a center point here, so it's easier to draw a circle now. So this circle here, let's make this the center. Yeah, the center hole. So that makes the center hole, and then we need one more, which is that little shoulder. So we'll type C again, and then this one is it tip or base? It's base diameter. So we'll type that in and hit enter. So now we have all of our diameters drawn in there. So now we can go ahead and start giving this thing the shape that it has. So now we're going to stop the sketch. We're going to get rid of the center part, which would put the hole in the center, and these four edges here, which will make the thing round. So hit Q for press pull, and we're just going to highlight them all in the center. I'm going to rotate around so you can see, and I'm just going to pull it through. And it's a cut operation. You just hit OK. So now we just made a cylinder, is all we've made. We can turn our sketch back on, and you can see right there is the part we need to get rid of to put that small shoulder in here. So I'm going to click right there. I'm going to try to click right there, and hit Q again. And then we're going to, oops, let's try that again. We're going to back this way. So it's want to do a negative cut, so I'm going to just put in here minus base to shoulder, or yeah, base to shoulder right here. And all this was defined in the settings beforehand. So there's my base to shoulder. So now we're going to turn on our other sketch. Let me go over here to the front, and we can finish pulling all these things out. So we need to do a press pull here to get rid of the material for the pen. It's a cut operation, and we just pull it completely through because it doesn't matter. And then one thing, this is user settings. Man, have I been doing this the whole time and nobody's been seeing anything? Golly. So let's back up. Leave it to me. Leave it to me. Not to look at the other monitor. Got so engrossed in my work. So we're going to back up. Alright, there we go. So, back up one more. What I did was I switched it around to this side, and we drew another sketch. Let me turn that sketch on. And we'll go ahead and edit the sketch so you can see. I drew a 3-point tangent circle using the three sides of the box as my tangent points. And since I didn't put any, what do you call it, dimensions on that outside circle, it'll always change with that box. And that allows me, I'll have a center point that I can draw these other two circles from. So these other two circles are dimensioned based on the user parameters that I put in at the very beginning. So after I got done with that, then we press pulled, oops, stop sketch. Then we press pulled, you know what, let's just go back here, and I'll just do it again. It doesn't take that much to figure out. We're just going to erase these three press pulls here. So delete, delete, delete. Alright, now we're back to our drawing. So here's a sketch on the front plane, and here's a sketch on the side plane. We need to get rid of this material and this material to create the hole and make the thing round. So the easiest way is you hit Q, then highlight the 3 parts, or 5 parts in this case. And since we're cutting it completely away, you just drag it through the profile and hit cut, and it's done. So now, let me turn this sketch off. We need to put the shoulder part in there, and it's another cut operation, but it's a dimension cut. So I pull it back a little bit. Since it says it's a negative, I'm going to put negative base to shoulder, and it automatically does that part for me. So now we have most of the part done. We need to put the cuts through for the bead profile and for the locking pin. So to do that, this top one's a cut operation. It's pretty simple. You hit Q and you just drag it through, And now you've cut your hole for your pin diameter. Now we need to do the profile for the bead. Again, we're going to hit Q for press pull, except for this time I'm only going to go half. I don't want to go all the way through. And in case this thing ever gets out of gets really dimension big or small, I'm going to go ahead and do it by a formula. So I'm going to put tip diameter divided by 2, and that should take me to the middle of the part. So if I go here so you can see, it'll always be in the middle of the part. No matter if we make these things 3 inches or 5 inches, it'll always cut to the middle of the tip diameter. So hit OK, and then turn off that sketch, and there we go. One glue tip nozzle ready to go, ready to be machined, ready to be printed, ready however you want to make it. The only other thing that I would probably do is put a short little fillet in here, just so it's not got that sharp edge. So you can define this in your radiuses too. So excuse me, you could put like a point, 25 thousandths radius in there, which is probably plenty, and that would radius that. You could radius the whole thing if you wanted to. So that's pretty much it. So let's see, let me spin it that way so you can see. Let me rotate a little bit. So I'll show you what I'm talking about, these user parameters. So, excuse me, if you wanted to change the overall length of it, like say to 4 inches, just hit 4 and enter. Oop, see, since we didn't do that cut all the way past, that might be one thing we can go back and fix. So if went back to this very first extrusion here, one of these extrusions, we need to, instead of pulling it through, we need to make it an operation where it's back to that formula. So that way that won't happen. You could do like the let's say overall length plus 5, overall length plus a half an inch or something like that. That way that cut operation will always go through. So that's why that did that. Let's see, we're going to change this bead profile. Say the engineers want this thing, 3/4 of an inch up here. So the tip height, the bead height, instead of being 0.615, say they want it to be 7 or 3/4. So you just hit that and it changes the bead height. So 0.615. Or if they want to change the bead width to 0.5, it changes the bead height to 0.5. So, or did I, I might not have did the 0.3974. We might not have did that dimension. So let's go back into let's look at this sketch right here. Let me close this. We're going to edit this sketch because that didn't change when I did it. Oh, yeah, see, I didn't put the dimension for the bead height. So that's why that didn't change when I did it. So hit D for dimension. This is what's good about using modeling software like this. You can go back in your timeline history down here and fix anything you see. So here to the bead height, which is the arc tangent of that right there, we need to make that the bead height. And hit enter. Alright, now we're good to go. So we'll go back down here. Come on now, work with me here. Live, doing stuff live, and this is what happens. Alright, parameter table's up. Now, if I change this to 0.750, it changes to 0.750. If I want a 1/2 inch bead at the bottom, it makes it 1/2 inch bead at the bottom. If I want to change the top radius to 1/4, it changes it to 1/4. And anything you want to change, so let's change everything back. 615. The bead width was 0.3974, and the bead here is 0.1. So that's how they're made right now at work. But you see how easy it is to change. Anything in the model environment you can change using these parameter settings, as long as you've dimensioned the parameters. And you could go in at any time, and we'll go back in here. Let me close this out and edit the sketch. If you didn't want to relate that to it, you could always put 750 in there, but it'll always stay that, and if you say you've already made a drawing and you dimension it this way, where you put all the dimensions in it, and then you say, shoot, I should have went ahead and made a table. Well, make your table out, and then when you come back here, you can do the same thing. You put bead height, or whatever you've named that dimension. So it's a very, very, very easy way to change drawings once you've drawn it. So now, we use these kind of nozzles throughout the plant. This one comes from the windshield area. There's one where they put adhesive on a roof cap. There's another one where they put them on metal to metal surfaces in the cabin white area. And I can't even name all the places. There's quite a few places. But this one drawing could serve for the whole thing. They all, basically the same thing. You just go and change the parameters, and then you could print them or machine them however you wanted to. So that was our drawing lesson for today. So we'll see what next week has in store for us. So if you have any questions, pop them up in the chat or whatever. The streaming software that I use lets me put, if you post a question in your YouTube or anything like that, I can get them up, or show anything that people want to know. Later on, there might be a couple of, let me see, how can I say this? Collaborations might be a good word. So the software that I have really lets me do a lot of stuff with it. So I can get callers in. Hey, John. So I'll just show you what I'm talking about. Let's do that right there. So he just texted or put it in YouTube chat, and I can pop it up there. So it's really, really good software. Was an email with Adam Booth last week, I believe it is. And I don't know. I'm sure anybody that's watching this channel is following Adam Booth. He got another viewer sent in that part that he was needing for the G&E shaper, and the one that we modeled 2 weeks ago. And he got back in touch with me. That one won't fit his, so we need to change the drawing a little bit. But I believe he's going to go ahead and machine it with the shaper. So the shaper that he bought is going to make a part that he needs for his shaper, which is pretty cool. So I know he sent that drawing to Mr. Pete or Tubalcane on YouTube, and I don't know if he's going to print out a 3D copy of the one that I drew or what exactly. But I sent a good drawing to Adam, and he should be getting back, and we'll get the measurements down pat before we do that. So anyway, I think that's it for today. John, I know you've been watching the Sidney Lathe stuff. Work has been hectic the last couple of weeks, so we've been wide open trying to figure out. We're getting ready to crank up another shift, and we're trying to figure out where people are going and all that. So it's been wide open. But I plan to get back on the Sidney Sidney Lathe pretty quick. Like I said, all the parts are off of it. I have to make some troughs. I couldn't find a plastic bin big enough to get the apron in, or the what do you call that thing? The saddle. So what I'm going to do is I'm going to get some 2x8s or 2x10s and screw them together and line it with plastic, because I don't want to use 100 gallons of purple power and just waste all that money. So we're going to put that stuff in there, and we're going to get that. We're going to get that stuff soaking in the purple power, and then we'll get to cleaning up on it. So it's getting there. I can't wait to get it back together. I have to get with American Rotary, or I have to get a phase converter. I don't think Duke Power is going to run that stuff out there cheaper than I can get a phase converter, my 3-phase power. So we'll get there. We'll get there. Alrighty. So I think that's enough for tonight. Everybody go watch the Super Bowl if you want to. Go grab you a cold beer if you want to. And just enjoy your night. Whoops. Of course. What do you know? Always something wrong when you hit big fingers hitting the wrong button. Anyway, y'all have a good night. See ya.